going to talk about the operational timeline. Now in this operational timeline, we have this black line on the screen that it represents engine RPM. And right now we're sitting at 0 RPM. We're waiting for something bad to happen. That bad to happen could be an ice storm, it could be a hurricane, it could be as simple as a squirrel on a transformer. And it caused the outage. And that outage is N1 and N2, which is your sensing wires for utility. And if you follow along in the diagnostic manual, you'll notice that these wire numbers are spelled out and their function is spelled out as well. So, N1, N2, delay timer is initiated. So we start that delay timer once we lose utility voltage. And the default is 5 seconds. However, we can adjust that anywhere between 2 and 1500 seconds. So we have 2 to 1500 seconds. Why would you want to go to 1500 seconds, all the way up to 1500? Well, that equates to about 25 minutes. There are cases where a customer may get nuisance outages and they'll just deal with the, let's say, a 10-minute outage rather than have the generator start 2 to 3 times a week. So for that reason, that is adjustable. In rare instances, it could be adjusted. At this point, once we've satisfied the timer, we turn wire 56 on. And when wire 56 is turned on, we get an instant increase in RPM. And once the engine is cranking, we're going to get a signal on wire 18. And wire 18 is that signal that comes to the controller and says, hey, I'm actually turning. Things are active here. I'm turning, I'm trying to get fuel in here, I'm getting that air fuel, I've got spark, and we make an assumption that we do have compression. So we're going to turn the fuel on when wire 18 is initiated. So we turn on wire 14, and when wire 14 is turned on, then with a properly operating engine, we're going to get an increase in RPM. And that increase in RPM is the engine actually running. And at 1500 RPM, on the way up, well, 1500 RPM, we're going to turn wire 56 off. If you recall, wire 56 was turned on so that it would crank. Now that we know it's running at 1500 RPM, we turn wire 56 off. And then at 2200 RPM, we're going to do something rather unique, and that is we're going to flash the field. And flashing the field simply means that we're going to flash the field so that the magnetism and the alternator can begin producing AC voltage. Wire 4A, as I said, turns on at 2200, and we begin a warm-up timer. That warm-up timer is 5 seconds. Not necessarily to warm the engine up, it is more of a stabilization timer, meaning that let's get the engine to stabilize first so that we can then take the load. Now, once the engine stabilizes, then we're going to see if we are at 80% of nominal voltage. If we're 240 volts, then whatever our 80% of that is, then we make sure that we're at that. If, for whatever reason, if on the outside chance that there is no voltage being produced by the generator, well, then we will stay in warm-up. So the controller, if you've ever noticed, will stay in warm-up mode if it doesn't produce voltage. Now, once it does, we turn off 4A. Okay? So we turn off wire 4A, and now we are ready to go. Everything's good. We're producing 240 volts. We're at 60 hertz frequency, and we're at 3600 RPM. Okay? 3600 RPM and 60 hertz are the same. They're just measured differently. One is measured in cycles per second. The other is measured in revolutions per minute. And then wire 23 is closed. We close wire 23, meaning we complete the circuit on wire 23. And when we do, it transfers. So now we get a transfer. And when it does, then we're good to go there. Now, the amount of time between 23 closing and utility coming back could very simply be anywhere between 5 minutes, let's say, or it could be upwards of weeks, depending on the outage, whether or not it's a catastrophic outage or long-term. So we have here a then return to utility. We start a return to utility timer, and when we do, that return to utility timer is non-adjustable, and then when that expires and it has been satisfied, we open wire 23. Transfer switch ready to go back? It does. As soon as it goes back, then we begin a cool down timer, and that cool down timer is also non-adjustable, and because it is non-adjustable, we're going to run 60 seconds and we're going to cool the engine down. We make the assumption that the engine has been running, has been carrying load, therefore it's going to be rather warm, and then wire 14 gets turned off. We turn off wire 14 first because we want to turn the fuel off and burn off any excess raw fuel that might be in the manifold or in the cylinder, so that we don't create a hot restart issue. And then we turn off wire 18. After we're sure that wire 14 or the fuel has been burned off, we turn off wire 18, and then we are set to go all the way back to 0 RPM. That is the operational timeline. Thank you for watching, and remember, at Generac Service Training, we believe knowledge is power.